Okay, see here, I wrote down some equations from the last video, right? Remember, sine and cosine, both of them are periodic functions, and they both have period 2 pi. And what that tells us is if you take any angle that's in radians and you add 2 pi times any integer, the output is going to stay the same. Okay, so again, let me say it again. If you take any angle theta, right, you add 2 pi times any integer to that angle, positive or negative, right? What's going to happen is the output will stay the same. Same thing with cosine, okay? Same thing with cosine. And not only that, sine of negative theta is the same as negative sine of theta. In other words, sine is odd. Cosine, as you can see here, is even. Cosine of negative theta is cosine of theta. That's really what we saw from the previous video. So what I want to do now is I want to use these equations to solve some other examples. So for instance, we're going to solve this example. So let's calculate sine of 13 pi over 6. Negative that. That's what we're going to calculate, okay? Okay, and we're going to do cosine of that. Okay, I wrote the pi first. There we go, 13 pi over 6. So we're going to calculate sine and cosine of negative 13 pi over 6, okay? Now we know a lot about sine and cosine when the angle is in the interval 0 to 2 pi. Okay, we know sine and cosine. We know sine and cosine of explicit angles in the interval 0 to 2 pi. And and it's really enough to focus on that interval because again, as I said in the previous video, once you know everything about sine and cosine in this interval or any interval of length 2 pi, you know sine and cosine at any angle out there. Okay, so negative 13 pi over 6 we have, but using the above, we know that if you do sine of negative 13 pi over 6, that's equal to negative sine of 13 pi over 6. Okay, that's good. So it's enough to know what sine of 13 pi over 6 is. Okay, so now 13 pi over 6, well, if you notice, 2 pi is the same as 6 times 2 pi divided by 6. And of course, that's 12 pi over 6. Now, why did I do that? Well, this is showing us that 13 pi over 6 is bigger than 2 pi. Okay? In other words, if we want to know what sine of 13 pi over 6 is, let's subtract 2 pi from it. Because 13 pi over 6 alone is too big. Okay, so let's do that. So we have 13 pi over 6. We're going to subtract 2 pi, which is the same as 13 pi over 6 minus 12 pi over 6. So what is this equal to? Well, this is going to equal to pi over 6. And again, this implies that sine of 13 pi over 6 is the same as sine of 13 pi over 6 minus 12 pi over 6. And that's equal to sine of pi over 6. Now, sine of pi over 6 is a half. So this is equal to 1 over 2. So altogether, we have sine of 13 pi over 6 is equal to sine of pi over 6, which is a half. So that tells us if you did sine of negative 13 pi over 6. That's negative sine of 13 pi over 6, which is negative 1 over 2. Now, what about cosine? Remember, we had to do sine and cosine of negative 13 pi over 6. Well, cosine of negative 13 pi over 6, if you remember, cosine is even, so this is just cosine of 13 pi over 6. And cosine is 2 pi periodic, just like sine. So using the calculations above, we get cosine of 13 pi over 6. That's equal to cosine of 13 pi over 6. This is not going to fit, so let me just erase this. We'll do this instead. This is equal to cosine of 13 pi over 6 minus 12 pi over 6. Okay? And that's equal to cosine of pi over 6. And that is equal to radical 3 over 2. So all together, we're going to get cosine of negative 13 pi over 6. That's going to equal to cosine of 13 pi over 6, which is square root of 3 over 2. Okay, so in the last video, if you remember, I said that tangent is periodic as well. Its period, though, is pi. So because its period is pi, that actually tells us that if you take any angle theta and you do tangent of theta plus pi times k, k is any integer out there, that's not going to change the output. In other words, this is going to be the same as tangent of theta. So if you take any angle theta, right, and you add pi times k, where k again is any integer, the output from tangent will be the same. Okay, so let's work with this. Okay, so let's consider this now. Let's find tangent of 7 pi over 6, okay? So that's what we're going to find now. You actually could find this using reference angles if you really wanted to, but let's use the fact that tangent is pi periodic, okay? Okay, so 7 pi over 6, tangent of that, well, it's not so obvious what that is, okay? But notice this. If we take pi, okay? If we take pi, right, that's the same as 6 times pi over 6, okay? And what does that tell us? That tells us that if you take 7 pi over 6, okay, and you subtract pi, that's the same as 7 pi over 6 minus 6 pi over 6. But what is that going to give us? That's going to give us pi over 6. So in other words, tangent of 7 pi over 6, that's equal to tangent of pi over 6. Now the question is, what is tangent of pi over 6? Well, if you remember, it's equal to radical 3 over 3. Hence, altogether, we get tangent of 7 pi over 6. That's equal to radical 3 over 3. So what I'm going to do now is I'm going to show you how to find tangent of 7 pi over 6. We're going to use reference angles, though. And also, I'm going to stay in radians. I mean, if you were to look at previous problems that I've done with reference angles, I was in degrees. You could convert this to degrees, I guess, if you really want to, but I think it's good practice to stay in terms of radians. That is to keep our angles in radians. Okay. Well, remember, with reference angles, we have to figure out what quadrant is our angle in. Okay. So we need to figure out what quadrant, okay, 7 pi over 6 is in. That is what its terminal side is in if we draw it in standard position. Well, again, if you were to draw, right, like so, drawing the Cartesian plane, here we had 0 radians here. Here it was 90 degrees, which is the same as pi over 2 radians. On the negative x-axis, that was 180 degrees, which is pi radians. The negative y-axis was 270 degrees, which is 3 pi over 2. And 0 is the same as 2 pi radians. 0 radians, 2 pi radians. Okay, so we have to figure out what quadrant 7 pi over 6 is in. I guess you could use a calculator, but let's make this more fun. We know that pi is the same as 6 pi over 6. Okay, that's good. Well, right away that tells us that 7 pi over 6 has to be either in the third or the fourth quadrant. Since 7 pi over 6 is bigger than 7 pi over 6, 7 pi over 6, is bigger than pi, that tells you it has to be in either quadrant 3 or 4. Well, let's see how it compares with 3 pi over 2. 3 pi over 2, right? That's the same as 3 times 3 pi over 3 times 2. So we're rewriting 3 pi over 2. So its denominator is 6. We get 9 pi over 6. So that tells us that pi, right, from the above, is less than 7 pi over 6. Here, let me just be consistent. And 7 pi over 6 is going to be less than 9 pi over 6, which is 3 pi over 2. Okay, so what does that tell us? That tells us that 7 pi over 6 must be in quadrant 3. So we're going to be in quadrant 3. Okay, that's good. All right, so what I'm going to do now is I'm going to draw that angle in standard position. So let's do that. So again, we have this is our coordinate plane. So in standard position, right, this is the initial side. The terminal side is this. Now, remember, this is pi, right? This is 3 pi over 2. We know that the angle is 7 pi over 6, okay? And we also know visually that the reference angle is the angle the terminal side makes with the x-axis. And it has to be between 0 degrees and 90 degrees. So in radians, it's between 0 and pi over 2. So this is our reference angle. Now, what is that, though? Well, that's going to be that angle, the angle in red, 7 pi over 6, right? Minus pi, but that's equal to 7 pi over 6, right? Minus 6 pi over 6, which is just pi over 6. So this is the angle in red. So this angle in red is pi over 6, which is right over here. Okay, so that tells us, and also since we're in quadrant 3, if you remember, let me just change the color one more time. All students take calculus. In quadrant 3, tangent is positive. It's the only one of sine, cosine, and tangent that's positive. The A, remember, means they're all positive. So this tells us that tangent of 7 pi over 6, okay, this is going to be just tangent of pi over 6. And we already know that tangent of pi over 6 is radical 3 over 3. So it's just another way to calculate tangent here without using the fact that tangent is pi periodic. We're using reference angles here.